Okay, just one quick thing before I do start. If you can just quickly put yes in the questions box. Hopefully you can all hear me. So if you can you just please put yes, someone, so you can just say you can hear me, just so I know that I can start without any issues. Okay, thank you. So yes, thank you. Okay, right, I shall get started. Okay, so welcome to this this robot structural analysis demonstration here today. So today we're going to look at a few things regarding the program and what it does and how it works. So we'll look at a bit of an overview of the program, how sort of industry trends, business challenges, and why you should use robot, and how you can utilize it with things like workflows with robot, robot and Revit. Now, robot itself is a structural engineering tool which is going to help you design your buildings or your structures within your industry. It's a tool that Autodesk has been pushing for many years now, which you can utilize. You can create your building analysis model within robot itself and produce documentation and drawings out of that. It's a tool that Autodesk are pushing as part of BIM workflow, so you can simulate your building analysis in a 3D model as well as doing your design at the same time. The sort of trends that we're looking at today in the industry is obviously building information modeling, and how robot can offer this potential analysis tool to design your structure within one environment. It also, with the current industry, helps decrease on construction spends, because you're doing the design and analysis in the same place rather than going into several different building models, etc. One thing it is, it definitely is more an efficient way to use a tool, because you can build an analysis model within robot, which you can also export out into things like Revit. The sort of like challenges that I think we're all looking at within the industry at this moment is to, one, decrease our budgets. Budgets are being cut all the time, so we're obviously looking at ways to save our money when we're doing and working on a project. Sort of environment we're in at the moment, it's a very competitive industry, and having tools like robot is certainly going to help you do your analysis and hopefully win more work off your competition within the industry. One thing that I think a lot of our clients certainly say to us is we spend a lot of time doing tasks and reworking over multiple things over and over and again, redesigning things. One thing that robots should be help to is maximize your efficiency within your organization to do the design in one place and redesign if required. Other challenges that I think a lot of people are coming up is coordinating the building and the analysis between the structure where it is and the analysis in the actual design package. So hopefully using things like robot should help you in every stage of your design process, whether it's early stage concept all the way through to your full design ready for construction. It helps you analyse small to large structures within the industry, from a small complex build, so a small simple building to a complex structure, whether it be a large high-rise building or a simple bridge, for example, within that. Now, you can analyse one model or multiple models at any one time. You can also use the cloud. There is actually a link to the Autodesk 360 analysis within there. The sorts of solutions that you will get from robot, it offers smooth workflow and interoperability between Revit structure. Okay, it extends the design analysis capabilities by enhancing the power of the software through its own API. Okay, and the API is actually open as well, so you can actually utilize that by building extensions onto that. It has a rapid analysis and integrated structural design tools built into the software to help you improve the way you design your structures. There's a lot of analysis tools which you can do in there, which I'll show as we go through, and we can see what sorts of things you can get out of robot itself. One key challenge that I think people are coming up with is the inefficient workflow between products. And now Autodesk offers a solution with their design software, with Robot, with Revit, with other tools. For example, Inventor in the manufacturing side is utilizing the tools and analysis into your designs and making it easier to use the workflow between product and product. One thing as well is transferring your data into your final design drawings, fabricated processes and things like that. So you can obviously do full design in here. You can do things like connection design as well. You can also do code checking within the actual program, so it allows you to check what you actually designed within the actual software itself. So the sort of solutions that it's offering is better management and integration of the actual structural design analysis within one place within the software. There is bi-directional links between Revit, the advanced steel, the advanced steel software. We have Revit extension tools, which are obviously between Robot and Revit. And like I said earlier, it does actually extend out to Inventor as well, but that's a slightly different analysis that it's going to do. It allows you to transfer structural information and fabricated drawings inside the actual software and perform analysis for Robot Structural Professional and make it smoother to translate the model and the results to things like advanced steel. And it used to obviously do AutoCAD structural detailing, which unfortunately is now discontinued. Okay, so the benefits you're going to get using robots is the collaboration, the bi-directional link between the softwares that Autodesk offer. Okay, it's also a fast, powerful tool to help you do your analysis within the software, elements of auto meshing, and efficient linear and dynamic sorry, it's a word I can't pronounce very well. Automatics, it says on the screen, sorry about that. And it's a versatile software which has the API open, just like things like Revit, so you can design extensions to do other things inside the actual platform. And it's something that's quite recent on the Autodesk Labs. If anyone is using things like Dynamo within Revit, you can now use Dynamo within Robot as well to build your analysis up, your model, using tools like that. So the sort of things you're going to be able to do within Robot itself is some analysis for concrete, steel and timber design. Okay, so it's making your design a bit more diverse, because you'll be able to design the reinforced concrete frame or the steel frame or the timber frame within inside actual one environment. It does have further capabilities. You can take the actual design further and utilize the tools for within inside Revit itself. We have auto meshing there, so it will actually demonstrate and show you in color, and you can show other elements of the analysis within there. For example, if you're showing your bending moment diagrams, you can highlight all that information in there, and it can be displayed on screen. One good thing about about Robot as well is the localization, analyze and reporting you can get from here. It's been set up with global markets, so you can use this in whichever language you wish and whichever units you wish, or codes within those countries. So, for example, being in the UK, you can use European codes, and they've obviously got the British standards still in there, so you can utilize those as well if you need to. Like I mentioned a bit earlier, the open flexible API inside the platform allows you to do some analysis within the program and actually add on custom macros within there to contribute to what you're doing. There's also links between Excel and the actual platform as well, so you can utilize extensions within those to build up your design, not just through the program but through the extensive tools within there. So just to conclude what I've just mentioned there, obviously it's a comprehensive design solution for structural engineering. It produces faster calculations, simulated models within there, and within obviously each version of the software, Autodesk are continuing to improve and vastly move on the software every year with extended tools and enhanced analysis within that. Also, it will continue to grow each year with the updates of any codes across the UK and the world to keep up with the growing needs for all the users it's going to be supporting. It has a good collaborative workflow between products. So, for example, you could have an engineer or a technician or a draftsman building a model in Revit, and then you can actually export it straightly across into Robot and have to rebuild it up again from scratch. But there obviously is some workflow things you've got to consider before we do that anyway. As I mentioned earlier, obviously it will integrate with other versions of software within the Autodesk platforms, predominantly Advanced Steel and Robot, but obviously you can use the Inventor side of it as well. And just which has been discontinued was Autodesk structural detailing application, which is no longer supported by Autodesk. So if I give you a quick overview of the software, so I'm just going to duck out of the PowerPoint and go into Revit here. Okay, so I've got a very, very basic model here, and what you'll see is in Revit itself, we've actually already applied in some loads. So we can build up the frame, the model within inside Revit, no matter what sort of information you're placing in. And you'll see here, there's a simple model. We put some columns, some slabs in there, some beams, some supporting foundations, and we can take this information out of Revit directly and straight into Robot. So from the analysis tab within here, you'll see we've got the Robot Structure Analysis link. If I select that, what it's going to do is going to open an application window now and look at sending the model across. Now, because I've not done this already, it's going to ask me to send. I can always update models within here and export them back across to Robot, and it will update the model across into there. Okay, I can also look at my sending options of the load cases and things like that. I'm sending across within that. So if I just click OK here, it'll start to run the process. Now, obviously, you need to have Robot analysis on your machine to do this. So what it'll do, it'll start running the application, and it will send the process through into Robot in a few moments. Now, this can take a little while in some cases, depending on the size of the model. If you've got a large model here, it can be a few moments. If you've got a, it can be a few minutes. If you've got a smaller model, it can take a lot less. Now, you'll see here, it's giving me some warnings here. So I'm just going to click last to look at the report. So it just goes through a report to actually say, this is what's happened, and it will highlight in here any issues it's gone through. So it's just actually telling you what's happened. So if I close that now, you'll see I can go across into Robot Structural Analysis, and you'll see in here, here's my model. Now currently this is shown as a plan view, so if I just switch into a 3D view, you'll see there's the actual frame it's taken across. Okay, now you'll notice Robot is slightly different to the actual layout of Revit. We haven't actually got the ribbon in here yet. We're hoping this will be something that will come across very, very soon, hopefully in the next release. So you'll see here we've still got toolbars in here, but I can actually go in and I can actually go into the display, and just like I can with AutoCAD and the other applications in here, I can go in here and start adding more toolbars. So you'll see I can go and customize the toolbars that I want in here, and rearrange everything within there as I need to. So I can go in and actually start to add in more toolbars as well if I need to. So you can see here, I'm just clicking on a few, and it's adding the toolbars appropriately. Okay, so again, we can select the ones we want. Obviously, depending on how many different ones we want, you'll see here I can just simply place them on and around the actual software like I can here. So, okay, and if you don't need them, again, we can just simply click on here and turn them off within the environment. Okay, so you'll see it's taken across the information. If I actually select an element, all it's showing is at the moment is the analytical line which you would use in Revit itself, and in the properties dialog box down here, it's giving you technical information of what that is. So if I was to build something in here, I could actually do exactly the same in here and actually transfer it across into Revit. I can actually display all the information as well as a full thick information that's shown as a column, a beam, etc. Now, we've already added things like the loads into Revit here. We can do the same with into Robot and start adding the loads. We can even build a model up into there as well. So it's an easy process to do that. You'll see it's obviously brought across all the grid lines, all the level lines in here, and it also shows them in 3D view at the moment. We have what we call an object inspector, which is, if we go back into Revit, it's similar to your project browser. It actually displays all the information. So for example, if I come to here, it shows me level 2. It highlights in level 2, this is all the beams. Just drag this out a little bit here so you can see this. You can see this is all the beams, columns, floors, walls, etc. that's actually within there. Okay. Just like you have in Revit, obviously, when it puts the door in, it creates an opening. So it shows that that's the opening for a door, window, etc., that you can actually utilize in here and do your analysis. All the information, whether it's an analytical line or whether it's the actual full solid of the element, you'll still be able to see what it is, and it gives it a number and a code in here. So, for example, I can come around here and actually highlight what the numbers are. Now, I'm switching between obviously the views. You can see here, I can go into a plan view. I can set the level that I want to work at and actually do my analysis in there. I can go and add loads into I can do load calculations. So in the top here, I've got my analysis properties. So I can go in and actually look at doing the analysis in here. So here we've got all the loads which are applied, and this is what's coming through from Revit. So whoever applied this in Revit would obviously can take it across here, and we can start to apply the rods in here. We can actually start running calculations as well. Now, obviously, when it runs the calculations, you may be sat here watching the analysis for a short period of time. And obviously, if you do come up with any potential issues, it will point it out to you. Okay, so depending on what you're running and how big the model is, depends on the length of time that it's actually running for you. So you see it's going through the analysis, and it's come up with a few issues in here as we're going through the analysis. So that's something I need to consider as I'm going through. And it's come up with some issues in here. Okay, so Robot will obviously point these things out. One key thing that is a great point to make now is if you're building a model, for example, with this in Revit, you need to make sure that it would be a true buildable model. So, for example, this column here would not be a column that runs from ground all the way up to the level, for example, 7. It would be a column which would be split into individual columns as the appropriate was to be built, as that's how it's going to do the analysis within here. Okay, so if I just show you how we'd build a model in here, I'll just quickly switch back into my PowerPoint for a second. So what I'm going to show you here is a couple of short videos just to show you what I mean here. So here we have a video, and if I put it on the right screen, that would be helpful. Okay, so here we have, oops, I've gone one too far, sorry. Okay, right, so here we have rather than do it, I build a complete model myself, I'm going to show you how it's done a little bit faster. So we've got a model here. We can go in and start placing in our grid lines. Whether it's in the X or Y axis, obviously we can specify if it's going to be alphabetical or numerical. We can also then put in the distance between each one. So, for example, if it's equally spaced, we can do it all at once. If individual spacing, we can obviously set each one individually and add it in. We can also put the stories in. So you'll see here it's put the story heights in, so the level lines appropriate to each story that we're going to work with. Whether it's a single story, whether it's a multi-story building, we can adjust that. As you'll see, we can go in and adjust the heights. We can put more stories in appropriately as we're working through it. Once we've done that, we can then start to build up the model within inside Robot itself. So we can go in and we can actually pick the actual serial sizes that we would require from the library in the actual program itself. So you'll see here we can choose the actual size, the different types of column, beam, etc. that we're going to choose in here from the big long list that we've got, which we can select. Now we're not adding all the ones in, we're just adding the appropriate sizes that we use within this project. So you can see here we're actually selecting the serial sizes that we're going to use, and we're going to add those in, and then in a moment or two we're going to go actually into the software and place them. So you can add in as many as you need or as many as you require for this individual project, and you can add them in appropriately. So there's an extensive library that you can choose from each country, whichever you require, and you'll see the list of the columns now selected. Once we've done this, we can go onto the screen and we can actually position them in the locations. You'll see we're now placing them on the screen. Okay. Now, as it's going through here, you can see it's placing them individually. We can do this as a process of we can paste one or two and then copy them around in the screen easy enough as it goes along. So you'll see it's placed in the actual column, and it's an analytical line at the moment, but you've also got in there the actual the support at the bottom as well, and how it's going to be fixed. So you'll see again same process, going across and placing the beams in, very similar to what you would do in things like Revit and Advanced Steel within that sort of platform as well. So you can see here it's just a little easy click and place, and it's placing the actual column, the beam for you as you go along. As you'll see now, change and adjust the view within inside the actual program and show what information we want to see. So you'll see here we've now turned on the actual name of the elements in the view, so you can see what those are. Okay, we can even customize different elements within here, so we can display how we show the information in here. So this is a quick how you can show the data and quickly update the actual keyboard shortcuts. We can then go in and we can actually place in some more bars within inside here. Okay, so you'll see it's just placing the actual beams across within there. Some of the terminology you might see, it says bars and so forth inside here. That's obviously just the terminology of the software and how it works within inside here. So you can see here we're placing in the actual beams within there. We can then go in and actually place in some more beams within inside for obviously your supports. Okay, so you'll see here we can highlight and we can select different locations and now place in our beams. So what it's done is placed in a node at a center or offset points along there, which we can now put our beams within, and we can go around and place in, all the beams and copy and paste them around. So you'll see we're just doing a simple copy here, and we're going to paste them again into the other bays along the actual program. Okay, so you'll see there you go. Let's paste a couple across there. Okay, simple as possible to place the information. Okay, so again we selected the elements and we're going to copy them and paste them in the next bays here, and it's a simple and quick process. So now all the elements are in, we've got all the bars, the beams placed in. We now have our first floor or our story 1, whichever you want to call it. Now highlighting the rest of the information in here, okay, and using the actual translator here, you can see it's a simple copy and paste process to place it above in the next level. Okay, so now we've built up a frame. Okay, you can see all the information displayed on the view. We can turn off and we can show it in different ways. Okay, so there is multiple ways how to show information, how to show and readjust the information displayed on the view. So now we're looking at the actual axis. Okay, you see we've highlighted the information in there on the screen. Okay, and now, excuse me, we've just changed the beams on the screen very, very quickly with just a few clicks. Okay, so you'll see here we can select information from each story appropriately without having to do any long-winded processes by selecting individuals. Okay, you'll see here now just put it in of bracing within that sort of in that side of the building. So you'll see again we can do the same process and we can copy that information up or across the actual view as shown. Okay, so as that's going through there, as you can see, okay, we can copy and paste it around and place all our bracing within inside our view here. So I'll just move that along a little bit. Okay, so now all the bracing is placed in, we can then start to look at colouring and customizing the view, so it highlights all the columns, all the beam sizes in the appropriate colours. What we can do as well, we can put in things like slabs within here. So this allows us to create the actual slab thickness and type of what our slab is going to be. So you'll see here in the dialog box we can actually go in and choose what the actual slab is going to be, the height, the name of it, okay, what sort of slab it's going to be, okay, and you'll see we can pick from the list the type of slab we're going to use and its depth height. So we put in the values within here, and once we're happy with everything that we've got, we can then go into our model and place it on the view and create our slab. We can obviously customize and create as many different types as we need, and you'll see here we've just applied the material which is going to use very similar to what you've got in Revit. Okay, you'll see creating a few different profile types that we're going to use inside our project. So once we've set them all up and give it the definite height within there, we can then add it into our selection list, which we can use over and over and again inside the project. So you'll see there we now have a couple already pre-selected and set up, so we can utilize within inside our project. Okay, so then it's a process of just going selecting the tools, okay, and then we can start to utilize them within inside the project. So you'll see here we're looking at the calculation model. I'm putting in the different elements in there so we can utilize the right tools for the right job. Okay, so let's move that along because we obviously don't want to see every single instance. Okay, so then we can go on and you'll see here we can start to add in our different types. So you'll see we're just doing a simple rectangular shape. It's picked a couple of points and it's now placed in the slab for us. So now we now have that slab within inside there, okay, and it's placed. Again, the same principle applies. We can select that and we can copy it up to the next level, or we could draw another one in. So you'll see here we've chosen the roof deck this time, and we're going to place this in, and we're going to define the location where it's going to sit. And again, because it's a nice simple rectangle, it's an easy draw. Okay, so that's placed in our slab at the first floor and the roof decking at the second story height. Okay, so we can have a look at a bit further. If we go into the analysis side, and you'll see in here, we can start to look at our supports. We can add in what type of support we're going to use. For example, we can put a rigid support in, being a pin base point. So you'll see here we're creating a new one, we're applying the fixed directions it's going to be. Okay, so as we do that, we can then utilize the different types that we want. Okay, it's going to apply the node, and we can set the node to which ones it's applying to at the base. So you'll see here we're now selecting the base of the actual structure and applying it. Okay, so it selects those nodes at the base of them and applies it to them for us on the screen. Okay, so it's a simple process. Again, once you've set them all up, you can utilize them again and again within inside the project. We can now look at them, or the information showing in tables within inside the actual platform. So you'll see here it's highlighting which node has got a support in there. Okay, we can then start looking at adding our load types within inside. So you'll see here we can set up a title for the name and add it in. So it's a live load, dead load, wind, whether it's snow load, for example, and you can set up the actual information within inside there. Okay, so you go through and give it its name appropriately on the screen. Okay, and once we've done that, obviously we can take it the one step further and actually start applying the loads within here. Okay, so we set up those. We can now go in, and you'll see here we've got our load cases set up. So once you've done that, we can then start to look at adding the information in a second. So you'll see it's just highlighting the actual the names of the actual slab. So we're picking on the load definition here, and we're going to start looking at applying the loads to the elements inside here. So you'll see we can start to apply in our information into here, and then applying our loads onto the actual screen in a moment. Okay, so you'll see you're putting in information, and we're going to apply the actual loads. So within here, you can see here we can actually adjust our job description information. So whether it's European codes, whether it's American codes, etc., what actual units you're going to be using, so you can define the data within inside the program. So we're just going to apply this load case now in here. You'll see we applied it to the actual element number. Okay, it gives an ID number to all the information in there. So each column, each beam has its own ID number, and you can apply it to those. Okay, so you can see here, because we knew what the number was, we could simply apply it to that element without having to click on that. You can simply go around and click on them as well if you need to do. So again, apply another load. You'll see here we can go in and actually apply, for example, a live load onto here to the elements as well. Okay, and the same sort of principle applies. Again, we can go in, we can actually apply a different kind of load, which is a snow load this time, onto the element. within inside the software, and make sure obviously you apply it to the right element, panel. Okay, you'll see here obviously we can go in and apply win loads as well that we've set up to the elements inside the actual program. Okay, and we can apply many different types of loads into here. These are just some simple examples to show you right now. Okay, so there you go. Once you've applied your information, you can see you can list it by table within inside there if you need to. So you've got the information within inside your model. Okay, so there's a lot you can do with this, and demonstrating obviously the sort of information you can place onto here within inside Revit. Sorry, within inside Robot. I do apologise. Okay, so as we're going along, we can continue to apply on different types of loads within here as we go through. So you'll see we can pick the elements individually and apply our loads to them as we go through. So you'll see there you go. Apply the load to the side on those beams within here. Okay. So, as we're going through, obviously, I'll speed this up a little bit so you don't want to be seeing all those. So let's go back a little. So you'll see here, once we've applied the loads, we can show in technical information live on the screen, in graphical display, whether in color, whether it be in figures or diagrams as well on side of the view inside here. So what we're looking at now is obviously looking at cladding. So for example, if we could apply some cladding to the side of the building, we can do that. And we can do some basic analysis on there as well. So you'll see here, it's drawing the cladding on now, and we can utilize this design at the same time. Okay, so again, just turn on the graphical display. Okay, now I'm going to apply again another load to that surface within here, so you can see the graphical display of the load as you set it up and place on the screen. Okay, so I'll speed up a little bit so you can go a bit further. So you'll see there we've placed the loads, and you can see currently we're displaying that in colour with the load information shown on the screen. There's many ways you can customize and adjust how things look on the screen. It's obviously down to you as the user to display it however you wish, but you can see here just going through changing all the information so you can display it in different ways and show what you need to show and what you don't need to show on the screen. Okay, so this is just going through the analysis on that there with some meshing. So you can see we can adjust, there you go, the cutting plane of what we want to see, okay, on the screen. Very similar to other software that you can utilize. Obviously, it displays it slightly differently, but you can see it's placing all the values on as well for you on the screen, so you can highlight that. Okay, so there's a lot of ways to display the data appropriately for your needs as you're going through your design and building up your structure with your analysis. We can then run through the calculations. You'll see here we can add in different types of load definitions in here. So we're putting a seismic one in here, and we can choose the appropriate design codes for this, as you'll see here as we're going through and putting the correct information into the calculations. So when we run the calculations, it gives us the correct outputs. So you'll see here, it's now given us all those listed in here, which we can utilize at any time. Okay, so once we've done that, excuse me, you can see here we can now mesh the screen. Okay, so what we're going to do is actually put in the actual distance. So when it generates the mesh, okay, you can define how close or how far away the meshing boundaries are. Okay, so it's running through analysis. Okay, you'll see it's coming up with some information there's a few potential errors on here. Okay, so it's obviously telling you there's some sort of issues you need to address before you finish doing your analysis. So you can see here it's going to go in and adjust the size. Okay, so simply changing the size of those within here, and now run the calculations once again, and hopefully this will fix the issue which has just been highlighted. There you go. Changing the size has now fixed that potential problem. Okay, so again, showing the information in a table format visible on the screen for you. Okay, so you can display, as you saw then, as meshing. Okay, and we can highlight the deformation as well, as you'll see in the view. Okay, so you can see how the building's going to deform, or the structure that you're designing. So as you'll see here now, we can look at different ways to show the information. For example, as you can see here, we're selecting the forces, and we can actually apply that, and then it's actually showing you what the force is actually applied. So there's an output you can get there with information stored, all the data, or calculated information that you've just applied to the model with inside there. So there's the load combinations which you can go in and you can apply as many as you require. Okay, so you can see all the load combinations that you've set with inside the model. Okay, so there's a very quick overview of the software. So hopefully that's been as of interest. If you want to learn a bit more, obviously you can visit the Autodesk website. So there's Autodesk website highlighted on the screen there. So autodesk.com/robot will take to the robot structural analysis page. If you want some more information, please contact one of your local sales team, or even send an email to sales@greytech.co.uk. All the telephone numbers at the bottom of the screen as well. So hopefully you found that informative and it's been of use to you. If you want a bit more information, please feel free to send me an email. I'll try my best to answer the questions that you send through. Thank you. I hope you found that informative, and hopefully see you on these webinars again soon. Thank you.